In this video, we'll see how to write the equations in slope-intercept form from word problems. In the equation, y equals mx plus b, the slope is the number multiplied by x. Slope at the same time is called rate of change, and it has to be a constant rate of change, same throughout the problem. So slope is multiplied by x, and b is the y-intercept. Y-intercept will be a cross point on the y-axis, and it's a starting point when we graph the line, and it will be called initial value or starting point. So for the first problem, we have the cost of $14 to buy a membership to a video store and $5 to rent each movie. So the initial value is the first payment that you make in order to join the video store. Then, to rent each movie, we pay $5 per movie. That will be your slope, $5 per movie. So on the graph, we have $14 for the membership, which is the initial value. So to join the video store and rent a number of movies, we have the cost. The cost will be our y-axis. So that is the cost increasing based on the number of movies that you're renting. So from the initial value, it means when you come to the store and you're not renting any movies, 0 for movies, you still have to pay $14 to join in. So $14 will be the initial value. Then we have the slope. The slope, or the rate of change, is the cost per each movie. So from there, for every movie that you rent, you have to pay for a movie for each movie, $5. So you go 1, 2, 3, 4, 5 for the first movie. That means that the total cost now it will be $19. 14 plus the first movie. For 2 movies, we need to add $5 more. So 1, 2, 3, 4, 5. And then if you want another one, add $5 more. 1, 2, 3, 4, 5. You want another movie, add another $5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, as far as we can fit on this graph. But then, for the other movies that we have after 8, we can't fit on this graph, but we still can calculate the total cost for 9 movies and 10 and 20 and 100 based on the information that we have. So as values go, first, when you go to the video store, you don't rent any movies, but you pay $14 for the membership. So 0.14 is your initial value. Then you start renting movies. So 1 movie, 2 movies, 3 movies, 4 and 5, and so on. So for each movie, we're adding $5. So that would be after the joining plus 5. $19 plus 5, 24. The cost after joining in 3 movies plus 5, 29. The cost after joining in 4 movies, add another $5. And then keep adding $5 for every movie that you rent. So this information can be written as equation in slope-intercept form because we have a linear equation, we have a line, we have the cost going up, we have the starting point, which is initial value, and then we have the slope. So initial value is $14, and that is again on y-axis. the rate of change. If we determine the rate of change, that is $5 per one movie. In the equation representing the cost is on the y-axis, so the cost goes up with all the movies that you're renting. We need to include the initial value and how many movies. So the cost is going to depend on our initial value plus 5 or 5 of 1 multiplied by the number of movies that you rent throughout time. So the cost depends on 14 plus 5m, which as slope intercept equation we can write y. Y is the y value changing or the cost changing. The cost is on the y-axis. 14 y-intercept plus 5x, where the x will be the number of movies, which is the number of movies along the x-axis. So in slope-intercept form, this can be written as y equals 14 plus 5x. Or we can change the variable to the need of the keywords in the problem. So the cost is calculated based on 14 plus 5 multiplied by the number of movies. So if I have a question, what would be the cost if Mrs. Smith joined the video store and rented 20 movies? I can't answer this question by looking at the graph because it's not in the limitation of my graph. But what I can do is use this equation that I created using the slope and the y-intercept to calculate the cost and substitute instead of the number of movies 20. So 14 plus 5 multiplied by 20, because the question is what would be the cost after we rent 20 movies. So we have 14 plus 100, where the cost will be 114. So that's what we say. Total cost will be $114. Let's see another example. It costs $25 to rent a boat. That is the original payment. $4 additionally for each hour on the lake. So $25 is like a deposit, and then additional 4 hours for each $4 for each hour on the lake. So we have Mr. Scott. He spends $41. How many hours was he on the lake? We can determine this from a chart where when you go on to a rental place and you're not going on the lake yet, but you do pay $25 deposit, then the cost is calculated based on how many hours you are on the lake, and for each hour you're going to be paying additional $4. So that would be 29. You stay 2 hours there, okay, add another $4 to the total, 33. All right, so how about 3 hours? Add another $4, 37. Well, you decide to stay longer, 4 hours. Add another payment, 41. And then you can just keep adding $4 for every hour. But then if it's a long weekend and I say the person was on the lake for 3 days, how many hours are in 3 days? So you're not going to just go 24 hours per day and then add 24 more hours and you'll just go and create a ginormous chart. That would be not very efficient. But what it will be efficient is to create an equation, and let's see how that looks like. So for our problem to start with, Mr. Scott spent $41. How many hours did he spent on the lake. So for the total of 41, he was there 4 hours. On the graph, initial payment is $25, so I'm going to mark 25, and then $4 per hour. So I have 1, 2, 3, 4 for the first hour, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Just estimate a little bit, but I'm creating smaller dashes so I can use them for reference. Then 5, 1, 2, 3, 4, 2, 3, 4. As far as I can, to just see that linear growth, because if I pay a constant amount per hour, the growth is a straight line. That's our slope. And answer the questions to create an equation. Determine the initial value, that is our $25 initial fee. The slope and the rate of change is the payment per hour, so it's $4 per hour. In order to calculate this cost, I'll label it C. In the cost, we include the original deposit and the payment for hour. The more hours you spend on the lake, the more the cost is going to be. In slope intercept form, C, or the cost, is on the y-axis. 25 plus 4x. X is the number of hours, and that is lined up with the x-axis. So in slope intercept form, I can write this as y equals 25 plus 4x. Using our key words from the problem, cost is calculated based on 25 plus 4 times the number of hours. What would be the total cost after Mr. Scott rented the boat and spent 24 hours on the lake? So now I can't read it from the graph, or I can make a big chart all the way up to 24. Or the most efficient way is to write an equation and determine that the cost will be 25 plus 4 times the number of hours, 24. Multiply 4 times 24, and that would be 96. And then cost will be adding 25 plus 96, $121. So total cost will be $121. Let's see another example. $10 to rent the bike. That's the deposit. And $2 for each hour of riding it in the park. As a chart, initial value for this situation, I am not going to write yet. I am just getting there. That would be 0 for X and $10 to just get the bike. But then, an hour later, I have to add $2 more to this total. An hour later, $2 more adding another hour, another $2, another hour, another $2. If I spend $20, that's another hour. Then I would be 5 hours in the park. On the chart, initial value, again, I'm not riding the bike yet, so that's 0. Number of hours is 0. The cost is $10. $10 deposit. $2 per hour. From 10, $2 per hour. $2 more, another hour. $2 more, another hour. 2 more, another one. for every hour you want to use it for, you're paying at the end additional $2. That's our linear growth. We have the slope, which is the rate of change, $2 per hour from 10 originally paid. So determine the initial value, that's $10. That's the cost, that's why it's on y-axis. And this is the initial cost. Determine the rate of change, that is $2 per hour. That is at the same time called slope. To write an equation representing the cost, we need to include the deposit and the $2 per hour. In slope intercept form, the cost is our y-axis. The initial value is the y-intercept, and then 2 times x is the 2 slope, or 2 over 1 multiplied by x, which is the number of hours. So using this equation, we can calculate the cost after any number of hours spent. So what will be the cost after Mr. Brown rented the bike and spent 4 hours in the park? The cost will be the deposit plus 2 times 4. So that would be 10 plus 8, which will be $18. So total cost will be $18. At the same time, this answer can be actually read in the chart or in our graph because we had a small number. So if I go back and look at my chart, after 4 hours, the cost is 18. And right here, the number of hours 4, I can read off the graph, the cost is 18. So we have the graph, slope intercept form of the equation, and using the equation to calculate the